This is exercise 100 on page 304, where it reads, according to a September 2008 poll and report done by Pew Internet, 62% of employed adults use the internet or email on their jobs. So they're giving me a probability of success, with the success being identified that they use the internet or email on their jobs. And that's equal to 62%, which expressed as a decimal would be equal to 0.62. What is the probability that more than 180 of 250 employed adults use the internet or email on their jobs? So we're basically wanting a probability that X is greater than 180 when we have a fixed number of trials equal to 250. Now, as soon as I read that I have a fixed number of trials, I feel pretty confident that there's a good chance that this might be a binomial setting. So the question is, does it satisfy the characteristics of bins? B means binary. Are there only two outcomes possible? And there are. Either they do use the internet or email on their jobs, or they do not. I, independent. Are the employed adults independent of one another? It's probably a safe assumption to say that they are. N, do we have a fixed number of trials? We most certainly do. We've got 250 of them. And S, is the probability of success the same for each of those 250 employees? And yet we're told that that probability is 0.62. Now, the method we've used to calculate the probability in a binomial setting is our table. The problem is our table only goes up to 250. So the question is, might n be large enough that we can use the normal curve to approximate this probability? And what we do first, in order to identify if the normal curve will give us a close approximation, is we check to see if n times p